This video will demonstrate how to do a confidence interval for one proportion. The general format for a confidence interval is a statistic plus and minus a margin of error. In past chapters, we've used margin of error equal to 2 times the standard error. If you recall, that gave us a 95% confidence interval based on our 95% rule. Now that we are using the normal distribution approximation, then we are going to use margin of error equal to z star times the standard error. Basically what this means is that we're going to be able to do other levels of confidence besides just 95%. Now where does z star come from? Z star is a critical value from the standard normal distribution. Z star marks off a specified area under the standard normal curve, and in general there is C area between negative Z star and positive Z star on the standard normal distribution. So let's look inside of StatKey and I'll show you how to find Z star. In StatKey, we're going to look at the theoretical distributions and choose the normal distribution. The default normal distribution that's in here is the standard normal distribution. So if I want to find a value of Z star, then I would click on to tail up here, and then I would just want to set the area in the middle box here to whatever my level of confidence is. So if my level of confidence is 95%, I could put 95 in there, it's actually the default, and the value down here at the bottom, this 1.96, would be the value of Z star that I would use. So notice that that 1.96 is really close to 2. So we've kind of been using a rounded version of this in our previous confidence intervals. Now let's suppose that I want to do a different level of confidence, say 90 or 99. All I have to do is click in this center box, change the value in the center box to be whatever my level of confidence is. In this case, I'm going to choose 90%, so I put 0.90 and hit enter. Now the value that's down here along the bottom, this 1.645, would be the Z star value that I would use in my confidence interval. Let's try one more time for a 99% confidence interval. This time I put 0.99 in the box and hit enter, and down here at the bottom that would tell me that my Z star is 2.576. Now in our class and in real life, basically the three level of confidences that are used most frequently are 90, 95, and 99. So if you just make a little list of those three Z star values, you won't have to go to all the work of reinventing the wheel and looking up Z star every time that you want to do a confidence interval. So here's our values again for 90 and 99%. If you recall, the standard error for p hat is equal to the square root of p times 1 minus p over n. The problem is when we're actually using this in an application setting, we don't actually know the value of p. P is the unknown parameter that we're trying to estimate by doing a confidence interval. So what do we do about that? Well, our best guess for p is p hat. So we're going to substitute p hat into our standard error formula when we're doing confidence intervals. So our formula for the confidence interval for one proportion becomes what you see right here. We're going to end up with p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. And this formula for the confidence interval is going to be valid if both the counts of successes and failures in our sample is at least 10. So the successes is going to be n times p hat, and the failures is going to be n times 1 minus p hat. Sometimes people like to think of it as the yeses and nos. So we want all the counts to be 10 or greater in order to use this normal approximation. Let's look at an example. In March 2011, a random sample of 1,000 U.S. adults were asked, do you favor or oppose sin taxes on soda and junk food? 320 adults responded in favor of sin taxes. We want to give a 95% confidence interval for the proportion of all U.S. adults that favor these sin taxes. So first thing we're going to do is define our parameters. And in this case, we're looking at one proportion, so we have one parameter, p, the population parameter. So the correct notation for that parameter is p, and p is equal to the proportion of all adults who would favor the sin taxes. Next, we're going to look at our sample statistic. So the statistic that estimates p is p hat. So the appropriate notation for our sample statistic is p hat. We calculate p hat by looking at the proportion in our sample who favor the syntaxes. In this case, we'll take the 320 people who favor it divided by the 1,000 total people in our sample to get a p hat value of 0.32. Next, we're going to check to make sure that we meet the requirements to do this test. The requirements for this test are that both the successes and failures are at least 10. So if I look back at my problem here, 320 were the successes, the people who favored the syntaxes. That's bigger than 10. And my failures then would be everybody who didn't favor the syntaxes. So if I took 1,000 minus 320, that is also bigger than 10, meaning that we do meet the requirements. Next, I'm going to find my z-star. So if you recall from earlier in the video, we saw that z-star for 95% confident was 1.96. Now I have my confidence interval formula and I'm ready to plug in all those values that I know. So I plug in 0.32 for my p hat, 1.96 for my z-star, and 1,000 for my n, and I get a formula that looks like this. To work on this formula, I'm going to start by working on the standard error portion, which is everything under the radical over here. Solving for that, I get 0.0148. So that portion of my confidence interval formula is called the standard error. Next, I'm going to multiply that by my z-star, the 1.96, which gives me a value of 0.029. That portion of my confidence interval formula, once I get everything done on the right side, is called the margin of error. And I'm just going to add and subtract that margin of error to my p hat value to come up with my confidence interval. So if I take 0.32 minus 0.029, I get 0.291. And if I take 0.32 plus 0.029, I get 0.349. So this right here is the confidence interval. We interpret this confidence interval the same way that we've been interpreting all of our confidence intervals so far this semester. We'll say that we are 95% confident that the proportion of adults who favor syntaxes is between 29.1% and 34.9%.